Okay, let's look at number 10 and number 11. So number 10, first thing I always tell you to do is look at the final destination. Our final destination is work. We want to know how much work is being done. So we're looking for W. The second thing I want to set up is the problem, the scenario, because that's honestly the hardest thing to get from these problems is understanding exactly what's taking place. So in this situation, we have a chandelier, and the chandelier is being put inside of a box, inside of a crate to be exact. And it's saying we can ignore the mass of the crate. Okay, it gives us the mass of the chandelier, but they put the chandelier in a crate, but we're ignoring the mass of the crate. The crate is then being pulled on a smooth surface by two forces that are parallel to the surface itself. What that means is that it's on the same plane as the surface. Okay, it's a little confusing, but just know that that's what they're referring to. It says the forces are at right angles to each other, but they're at 45 degrees in either direction of the movement of the chandelier. So I'm actually going to draw that for you right now so you can see what they're talking about. Okay, so here's what you have. So I'm going to draw the crate. I'm looking at this from the top. So pretend we're looking at this from above. We're a bird, we're flying, we're looking down on this. We're looking down on this. So this is what you have. So this is your crate. I'm going to draw a dotted line for reference. So this is our y-axis, okay? So this is your crate. The displacement is forward, okay? So I'm gonna draw this. This is your D. Okay, the displacement is forward. Okay. What it's saying is that the forces are going to be at 90 degrees to each other, right? The forces are at 90 degrees to each other, but 45 degrees to either side of the direction in which the chandelier is moving. So the chandelier is going this way. You have somebody pulling on this side, F, and you have somebody else pulling on this side. Okay, and I'm going to erase the D real quick just so I can have more space. And what they're saying is that these two angles right here, both of those angles are 45 degrees. And if both of them are 45 degrees, that means that little V shape that you have right there is your 90 degrees to each other. So they're 90 degrees to each other, but they're 45 degrees on either side. So this is what they're talking about. So this is the situation that you have. You have a crate here, you have somebody standing here pulling from this side, and you have somebody standing here pulling from this side. Okay, so this is the situation. The F is this value. So F is going to be equal to, let me erase this so I can have more space on this side. So both F's are the same number, and that number is 1.2 times 10 to the 3, which would be basically 1200, okay? So this is 1200 newtons. Okay, that's 1200 newtons. And now we can start setting up the problem. So let me erase the bottom of this dashed line now that we have the idea. So W is what we're looking for, and that is equal to F times D times cosine of our angle. Okay. Now, temporarily, I want you to pretend that we don't have two forces. Pretend we only have one force. Okay. So ignore one of these for now. ignore 1, okay? And just let's say we're ignoring this one, okay? Pretend this force right here doesn't exist. Pretend it doesn't exist. If we did the problem with only one of these arrows, your F in this case would be your 1200. Your D would be 12. So let me write that down just so you can. From the problem, we have D is equal to 12 meters. And I also want you to notice something else. They told us the mass of the chandelier. They told us that the mass of the chandelier is 9.7 times 10 to the 3, but you don't always need the information that they give you, okay? Because the only thing we need to answer this question is FD and cosine of the angle. We don't need the mass in this case. So just because they give you a number doesn't mean you're always going to use it, okay? So remember that. You're not always going to use all the information they give you. So back to the problem. Let's say we're ignoring one of these arrows. The F would be 1200, so you would plug into 1200. The D would be 12, you'd plug into 12. And cosine of the angle would be 45, you'd plug that in and you would get your answer. But now, because we have a second force, we need to add that to the F. Now, this is actually very simple to do in this case because this force happens to be exactly the same as this force and the same angle. So all we need to do is just simply double whatever we get. Okay, so since we have two forces in the same direction, your final answer is actually going to be F times D times the cosine of this angle times 2, since we have two forces that are exactly the same. Okay, so your final answer for 10 after you plug everything in is going to be W is equal to, your F is 1200. Make these separate colors for the sake of visibility. D is going to be 12 times cosine of 45 times 2. You put that on your calculator, you will get your answer for number 10. Okay, that's number 10. Okay, I'm going to erase everything. And now let's do number 11. So number 11, final destination. Again, we're looking for work. How much work is done? We're looking for W. Okay. We are given D. D is 20 meters directly south. So that means straight down. Okay. So what do we have? We have a flag. We're given the mass of the flag. And we're given two forces. One force is to the east and the other force is 30 degrees south of east. Okay. Okay. So now let's draw the scenario. So we have a flag. The flag is on a flagpole, and we need to bring the flag down. So how are we doing that? Let's draw the scenario just so we can make it easier. So a flag is a rectangle. So again, I'm just going to draw a box, okay, just for the sake of simplicity. And now I'm going to draw an axis, both x and y. Okay, just for the sake of visibility and for the problem so we can see exactly what's going on here. So now let's draw our forces. I'm going to use blue for the forces. So it says we have one force going directly east. So east is to my right. So directly east means it's exactly on that x-axis, okay? Directly east, directly to the right, with a force of, this is going to be 8,000, okay? So this is 8,000 newtons. 0, 0, 0. And now I have, let me fix that 8. This is 8,000. And then it says I have another force that is 30 degrees south of east. Okay, so this is going east. I have a second force. This angle right here, this angle is 30 degrees. That's 30 degrees. And this has a value of, this is 5,000. Let's put the units on it. That's newtons. This is newtons. These are your two forces. And now, my question to you is, where's the displacement? The displacement is directly south. So because displacement is directly south, we can ignore one of these forces. And the force that we can ignore is the 8,000. And the reason we can ignore the 8,000 is because if you remember from problem 10, in problem number 10, we also had two forces. And we had to add those two forces because both of those forces were being contributed to the displacement. But in this case, we have one force going directly east, and the displacement is directly south. If you have that, what is the angle between them? The angle between them is 90 degrees. So if the angle is 90 degrees, that means that cosine of 90 is 0, and you don't get any work from this force. So that 8,000 is not going to give us any work in the direction that we want. So we can ignore it completely. So we're ignoring the 8,000. It is not necessary for us to answer the problem. It's the only force we need to look at is the 5,000. So now we have everything we need to answer the question. Again, W is equal to F times D times cosine of our angle. But again, reminder, this is the angle between F and D. The problem says that this is 30 degrees south of east. So this is 30 degrees south of east, but the angle between the D and the F is not 30. This is a different angle. So I'm going to use a different color. Let's use, can I get an orange? So this angle right here, this angle is not the same as 30. If this is 30, how much more do we have to go to get it to go directly down? That would be 60. So this angle right here is 30. That's 30 degrees south of east. But the actual angle between the D and the F would be 60. So just know that the number that goes here is 60, not 30. So now we have everything we need to answer the question. So if we plug everything we have in, we get that W is equal to, I'm just going to do this a little faster now. Our force is what? Our force is 5,000. So this would be 5,000 times our displacement. From the problem, it says we're going 20 meters south. So that's 5,000 times 20 times cosine of 60. Okay? You're putting in 60 degrees in there. All right. So you plug that into your calculator and you get your answer for number 11. Okay? The rest of them should be similar format. These are the last two problems, so these are the hardest two of the bunch. Okay? Rest of them follow similar formats. Okay? So the last two looked for work. In some cases, you're looking for force. In some cases, you're looking for displacement. Okay? Depending on the scenario, you're going to need different things. I saw one of them ask for weight. So number 5 here says you're looking for the weight. So weight, remember, is a force. Okay, so basically you just need to find, after you do go to the problem, whatever F is, that F is going to tell you how much the turtle weighs. So even though it says weight, that's weight is a force. So in this case, you're looking for F. Okay, so best of luck with the rest of it. Again, if you have any questions, you can always feel free to ask. Okay, best of luck and enjoy the rest of your day.